hi, my name is Naveen. I'm a rising senior at Washington High School. So the first couple of days of Bootcamp, I spent some time doing my starter project. And my starter project was a TV beacon remote. And basically what it does, it sends an IR signal to any screen that has an infrared sensor to it and tells it to turn off. Have you guys ever watched those YouTube videos where there's like a funny prankster who like behind the screen, for example, it's just like a bunch of people watching like a sports game, and like behind the screen like turns it off, and everyone's like, oh my god, what happened? Why is the screen off all of a sudden, right? Yeah, it's basically that. And so the reason why I chose that project was because I want to like try it out, see if it works. And yeah, it was pretty cool. So now moving on to my main project, the project that I did was the object detection using machine learning. That also uses a Raspberry Pi. So and I also created another functionality too. I'd like to also create a smart security camera. Functionalities that I had was number one, using a Google Coral to accelerate the performance of the object detection. Number two, creating a real-life application, which in this case was a smart security camera. So first, before I go into that, I would first like to explain the basic foundation of this. And I think in order to do that, it's very important that you guys understand the foundation of what a neural network is. So what is a neural network? A neural network is basically a framework that allows the Raspberry Pi to essentially be able to operate similarly to how the neurons in our brain interact. And this gives it the ability to predict what an object is, hence machine learning. Machine learning is basically applied statistics. It's using algorithms to be able to predict what an object is, which is what I've been able to do. And a neural network is able to do this by using a trained model. And a model is basically a methodology or an algorithm that the Raspberry Pi is able to use to be able to predict these types of objects. And training a model requires inputting thousands and thousands and thousands of images of different types of objects. And basically what the Raspberry Pi is able to do is it's able to analyze the similarities between this object, use pattern recognition to be able to essentially learn what the object is, hence machine learning. And for the two modifications that I added, I first added a Google Coral USB accelerator, and of course that's probably like something that you probably just don't understand, like what is a Google Coral. And basically what happened is that the Raspberry Pi, the processing power is very low. So initially when I ran object detection, it was very laggy, it wasn't very accurate. So I basically needed more processing power. So I added a Google Coral USB accelerator, and because of that, I was able to get instantaneous object detection and higher accuracy and a higher FPS. And the second application that I decided to do was a smart security camera. And what it does is that it detects motion, and it uses upper body, lower body, and face detection to detect if a human approaches it. And it takes a picture, and it sends me an email with a security alert with the image attached. So as I saw in the video before, right? There was like an image with like a green box on it. That was the image that sent me, and on that image, it used lower body detection. And the most challenging part of my experience was just mainly researching about this and having to troubleshoot the program. Because initially when I decided to do this project, I had like a whole plan out. I had all these steps, like, okay, everything is going to work according to plan. I'm just going to know how to follow these steps. Very easy to do. The first step, nothing works. Like what is this? Like I have all these steps and nothing works. I was very frustrated. I was very mad, stressed, tired, confused. Like how is this not working, right? Shouldn't everything be working? So I had to sit down and go through hours and hours of basically researching and debugging all the errors one by one to finally be able to get it to work. And not only that, so like experience that I had that was, I guess, a little bit traumatizing was, alright, so I was finally able to download a program, right? 30 minutes after, the SD card breaks. Right? So I had to start from scratch all over again. I had to reinstall all the programs I had trouble reinstalling. But luckily, that only took a day because I actually knew what I was doing this time. So that was really fortunate. And the next modification that I want to do is that I want to create more real-life applications for object detection. Because I think that this really has a good place in the market of the technology industry. So for example, some of the ideas that I was thinking of was for example, having it detect like the car license plate numbers. And if it sees anything invalid, and then it would send like a security alert, or also create like a system where if a person walks in a classroom and walks out, it checks them and checks them out, like the Amazon Go store, if you guys are familiar with that. And there's also a lot of different functionalities you can do with this. You can also put this on like a drone or like on different like vehicles. And also, if you guys have seen the Iron Man movie, if you guys know how like Tony Stark wears his mask, and it's just like missile detected or like all these different types of objects. I think that's like something that's like really cool in the future. So that's like one of the main reasons for why I wanted to choose this project, because I think it has like really like a futuristic feel to it. And overall, my experience at Bootstrap was very important to me because number one, it gave me some software and hardware experience. Number two, it showed me the potential that I actually had, because if it wasn't for Bootstrap, I would have known that I could actually work with a neural network. Because initially I thought like a neural network is something that like graduate students like work with, like how the high school students supposed to work with a neural network. But fortunately, through Bootstrap, I was able to like recognize that I could actually use this, and it taught me how that I can always push myself out of my comfort zone and to continue to challenge myself and go through like more experiences. And thanks to Bootstrap, I will definitely be continuing to push myself out of my comfort zone and explore the field of computer engineering. And thank you. That's my project.
What is the range the security camera can detect for like people?
So because like the Raspberry Pi processing power is really low, the model is like a little bit inaccurate. So it took me like a couple of tries to be able to actually get a picture. So like what I had to do is that I had to like walk in front of it and like walk away, and then slowly because like my body's there like for all those frames, right? Like kind of like finally detects that I'm there and then takes the picture. But of course if someone just like walks in and walks out, it's not going to detect anything. So I think like about like 10, not 10 feet, like 5 feet maybe.
What kind of objects can it detect?
So it can detect 90 different types of objects. So this ranges from like apples, oranges, chairs, laptop screens, mouses, keyboards, horses, it's a lot of stuff.
Did you have to give a fair amount of data to train it to find those
Yeah,
objects?
so the model that I actually used was pre-trained because I was kind of more focused on like creating different functionalities rather than just like creating like the base foundation.
Have you thought about using Google's TensorFlow for this?
Yeah, so I actually did use Google TensorFlow. And TensorFlow is, if you guys don't know, TensorFlow is an open source library with all the machine learning modules on it, and I was basically able to access those modules to be able to use this project.
Do you have any ideas on how you're going to solve that issue where it's not able to actually going by very quick? Like, what's the solution? What could be a possible solution for that?
So the solution is, again, using the Google Chrome. I didn't use the Google Chrome for that because initially I tried, but for some reason, it wasn't putting the bounding boxes like the green box you saw in the image. It wasn't putting that for some reason, so I had to opt out for using the model that wasn't as accurate. But in the future, I hope that I can investigate this issue and try to actually use the Google Chrome, and I think that would get me better results.
So when you're making your smart camera, why do you use like a lower body versus upper body versus face?
Okay, so the smart security camera was designed to only detect humans. It wouldn't detect like a cat or a dog like walking by. So because of that, I wanted to like detect like a whole person. So I use face detection, upper body detection, and lower body detection.
I noticed numbers by the boxes or whatever. Is that like the percentage of accuracy?
Yeah, so that's a probability. So it was running through the algorithm, and it was comparing it to the data set to see like what is the chance that that object is, like for example, if it was like shining at like an apple, right? It was running through the algorithm like in the neural network, and it was spitting out a percentage of the probability that the object is like an apple, right? And that was the numbers that was showing, like 97%, 67%.
So you have to set a threshold for that
Yeah, so I'm not sure I want to get too technical, but alright, I'll try anyways. So a neural network is comprised of an input layer, a hidden layer, and then an output layer. So the input layers have like all these different parameters. So when you shine on the object, right, when the object fulfills the parameters, it goes to the hidden layer, and that's where all the algorithms are. So then it goes through like the minimizing error function, all the algorithms to be able to determine the probability, and then in the output layer it spits out the probability and determines the object.
So just a very quick follow-up on that question. Like, so what is the threshold? Like, what percentage does it show to start showing the boxes?
So the boxes, so the threshold, or sorry, not the percentage. So what it does is that it compares it against like a lot of different objects that it thinks it could be, but then it chooses the one with the highest power percentage. So for example, if I once again shine it at the apple, right? You can say apple like 56%, but then you can also say car, but then that's 2%, right? So then it chooses the one with the higher probability.
So your model is installed on the Raspberry Pi?
Sorry.
Like you're using a Raspberry Pi for this?
Yeah, I'm using a Raspberry Pi.
And the model is installed on that?
Yeah, I'm also installed on this.
How much memory does the model take? How much memory is it taking?
Oh, the memory? It wasn't that much memory, but it took me 40 minutes to install. So.
Wow. I mean, that seemed like a lot of things you had to render.
Yeah, and the reason for why it was like instantaneous was again because the Google Coral USB accelerator. It wasn't just the Raspberry Pi alone. I had something that would help the Raspberry Pi to be able to process it. Yeah, so the memory wasn't exactly a problem.
Is there a way to limit the type of object you want to identify?
Yeah,
Instead of like opening it up for everything? It was trying to process too many things, so whatever was in sight, right?
Mm-hmm. Yeah, so the data set that I was using had 90 different objects, but of course I can just create a data set with one object, right? So then I can only detect like a human or like whatever object.
Okay.
Do you plan to use the Google API to set it over the cloud?
Oh, the Google Cloud API? Yeah, I was planning on using that. I was trying to research. I was like researching that, but I wasn't exactly sure how to use that. But then I came across the Google Coral USB accelerator, which I thought would be more interesting to use.
So these 90 models you downloaded from somewhere and get
Yeah, so what I did was that in TensorFlow, so the model I used was called the NobleNet SSD model. So I was able to download that model, and in that model I had a data set of 90 different objects.
Sorry, another long question. So, does the Raspberry Pi have a way of running a model? I'm sorry.
Yeah,
You
so-
said you installed it, so I was just curious.
Yeah, it's fine. So, so the Raspberry Pi processing power, because it's running a neural network, right? It alone, it causes the object detection to be very laggy, very slow. So I didn't have a video of it, but like when I was waving across the classroom, right? It would be at like a 0.8 FPS, right? Which is extremely low. The accuracy, like it was detecting humans and dogs, right? It wasn't very good, and that was because again of the processing power. It just wasn't enough. So that's why I had to use the Google Coral, which lends it the processing power. Alright, thank you.